Okay, think about this. What if the most common heart defect you could be born with was so confusingly described that doctors around the world couldn't even agree on what to call its different types? Well, for decades, that was the reality. But that confusion, it's finally over. Today, we're going to decode the brand new universal language for the bicuspid aortic valve. So, what are we actually talking about here? At its core, it's actually pretty simple. A normal aortic valve, which is basically the crucial gatekeeper for blood leaving your heart, it has three little flaps, or leaflets, that open up in this nice, neat triangle. But a bicuspid aortic valve, or BAV, only has two. And that simple change makes the opening more of an oval. And believe me, that one little difference changes absolutely everything. And this isn't some super rare, obscure condition we're talking about. Nope, about 1% of the entire population is born with this. To put that in perspective, that's tens of millions of people all over the world walking around with the two-leaflet valve. And a lot of them don't even know it yet. All right, so here's our game plan. First, we'll get into the basics of the valve itself. Then, we're going to untangle this Tower of Babel problem that was plaguing medicine for so long. After that, we'll dive into the elegant new blueprint for both the valve and the aorta. And finally, you'll see why having this one common language is such a massive game changer for everyone. Okay, let's start with the fundamentals. We're talking about the most common heart condition someone can be born with. So you can see why understanding it isn't just some academic exercise. It's absolutely critical. But here's the thing, and this is really important. The problem isn't just about having two leaflets. Experts have a specific name for this now. They call it a valvulo-aortopathy. Now that sounds like a mouthful, but it's a really key term because it means the condition affects both the valve and the body's main artery, the aorta. This double whammy is what leads to such a huge range of outcomes for different people. You know, for years, the biggest challenge wasn't even the condition itself. It was how we all talked about it. It was a true medical Tower of Babel. So many different naming systems causing so much confusion. Which, it kind of begs the question, right? Why on earth would you create a new naming system when there were already so many out there? Well, the simple answer is that all those old systems, they just created more chaos than clarity. I mean, just look at this mess. One system calls something a type 1, another system calls the same thing a type 2. Some use this crazy mix of numbers and letters. The Sievers classification even threw a one-leaflet valve into his bicuspid system. It was a total nightmare. You couldn't compare research from one hospital to another, let alone from different countries. And let's be clear, this wasn't just some nerdy debate for academics. This confusion had serious, real-world consequences. It was holding back research, it made it harder for surgeons to plan really complex repairs, and it made it impossible for doctors to figure out if one type of valve was more dangerous for a patient than another. Something had to change. And so out of all that chaos came this beautiful solution, a new, much simpler blueprint. An international team of experts got together and created one common language that everyone, everywhere, could finally use. And this is it, the heart of the new system. It's so elegant. Instead of a bunch of confusing numbers, there are just three main descriptive types: fused, two-sinus, and partial fusion. That's it. It's simple, it's intuitive, and it's based on what the valve actually looks like. First up, we've got the fused valve. This is the most common one by a long shot. You see it in over 90% of cases. It's exactly what it sounds like. It forms when two of the three baby leaflets fuse together as they're developing. This leaves behind a little fibrous ridge, kind of like a seam, called a raphe. And spotting that raphe is now a huge part of the diagnosis. Next is the two-sinus BAV, which is a lot less common. See, normally you've got three little pockets at the base of the aorta where the leaflets attach. Those are the sinuses. Well, this type just forms with only two sinuses and two leaflets right from the very beginning. There's no fusion, no seam, no raphe, just a clean two-leaflet valve. And finally, we have the sneakiest one of all, the partial fusion BAV. This one is tricky because it often looks just like a normal three-leaflet valve. But if you look really, really closely, you'll find a tiny, incomplete fusion right at the base. They call it a mini raphe. It's a super mild form, but being able to identify it is a big deal because it might explain why some people with seemingly normal valves still end up with an enlarged aorta. Now, remember what we said earlier? This whole thing isn't just about the valve. So the new system also gives us a clear way to talk about what's happening with the aorta, that aortopathy part of the condition. And this quote from the big international consensus statement just nails it. The congenital BAV condition is fundamentally a valvulo-aortopathy. You just can't think about the bicuspid valve without also thinking about the aorta. The two are completely linked. So this new language classifies that aortopathy into three main patterns. The most common one, we're talking about 70% of cases, is the ascending phenotype. That's where the main tube-like part of the aorta gets bigger. Then there's the root phenotype, where the enlargement is right at the base. And sometimes you get what are called extended phenotypes, where a few different parts are affected. Classifying it like this really helps doctors predict a patient's risk down the road. So, okay, we have a new language for the valve, a new language for the aorta. Why does this matter so much? Well, because the impact of this is felt everywhere, from the research lab all the way to the operating room. Just think about it for a second. Surgeons can now use precise terms to better plan a really delicate valve repair. Interventional cardiologists have a much clearer map when they're doing less invasive valve replacements. Geneticists can finally start to connect the dots between specific valve types and the genes causing them. And maybe biggest of all, researchers can now pool their data from all over the world, knowing for sure that they're all studying the exact same thing. This just puts progress into hyperdrive. And this right here, this is the real payoff. For patients, for their families, this one unified language means their doctors can give them a much more personalized idea of their risk. It means the cardiologist, the surgeon, and the radiologist are all speaking the same language. They're all on the same page. And it means that new treatments and new discoveries are going to arrive so much faster than ever before. Creating this common language was absolutely the essential first step. It has completely unlocked the potential for global collaboration on a scale we have just never seen before for this condition. So, I guess the real question is, now that the whole world is finally speaking the same BAV language, what incredible secrets is this tiny two-leafleted valve going to reveal to us next?